Local programming on KRWG Public Media made possible in part by viewers like you. Thank you.
Hello and welcome to Fronteras, a Changing America. I'm your host, Anthony Moreno. A recent U.S. Department of Agriculture grant will help researchers at Western New Mexico University explore how nano-agrochemicals may play a role in the future of agriculture. Here to tell us more about the research is Dr. Illya Medina, Assistant Professor of Chemistry at WNMU. Dr. Medina, thank you so much for joining us for the program to talk about this research.
Thank you for the invitation.
Now, I'd like to talk about the research, but first, if you could share with the audience, what are nano-agrochemicals?
Okay, well, nano-agrochemicals are part of nanotechnology, which is, lately a boom. Nanotechnology involves the study and the application of materials that are at the nano size. When we talk about the nano size, these ones are way smaller than conventional chemicals or materials that are in the market. The nano size materials have dimensions between 1 and 100 nanometers, which is about the size of a virus, right? So that's for you to have an idea of how small these materials are. And nano-agrochemicals are just chemicals that are manufactured in these small sizes with the idea of being more efficient for agricultural practices.
Okay, so share with us a little bit about the research that you have going on there. It looks like you're in a lab right now and some research plants are right behind you, but if you could tell us about the research that you have going on right now with the students at WNMU.
Yes, here at Western New Mexico University, we recently got U.S. Department of Agriculture grant to study the application of different nanomaterials for agriculture. The idea behind this is that we want to look at these different materials. We're testing zinc-based materials, copper-based materials, manganese-based materials, silicon-based materials, and we want to use them as nano-fertilizers, nano-pesticides, right? We want to see if these materials can work more efficiently than traditional agrochemicals. So right now we have 4 undergraduate students performing research in different crops. We are testing corn, bean, pea plants, jalapeno plants, and the most important part of this is that we're using local soil from here in Silver City. And this is important because we are trying to rescue those soils that are left behind for agriculture and see if by using these agrochemicals, we can actually use soils that no one is looking at.
So tell us a little bit more about where you think this research is going and what you've discovered so far.
Okay, well, recent studies have shown that these nanomaterials are more efficient than traditional chemicals. And this could be beneficial in terms of cost, right? Because we're gonna talk about using less amounts. And most of the agrochemicals that are used in agriculture end up lost either in the air or in the soil, but the plants don't really take them. The hypothesis behind our research is that these nanomaterials are so small that are gonna be easily taken up by the plants. So they can be used faster and more efficiently. So with this, of course, the idea is to reduce the cost, but also enhance crop productivity and the production and the nutrition of the product should be improved as well.
Now, obviously, agriculture producers are, I'd imagine, very interested in research like this, especially when you're talking about cost and efficiency. but we also live in a time where food insecurity is becoming a major issue, not only across the globe, but in our state of New Mexico. How do you see this type of research playing a role with food insecurity here in New Mexico and across the globe?
Well, actually, that's the main motivation behind this research, right? When we know that it is estimated by 2050, we're going to have a food shortage because of population growth and of course climate change. So a lot of the soil that used to be used for agriculture is not suitable anymore. So that's why we are looking at this, because we are trying to use land that cannot be used anymore by recovering it through the application of these nano-agrochemicals. We're also looking at fighting stress in the plants. You know, salt stress or drought stress can be fought easily and better with nano-agrochemicals. So in general, this should improve food production, not only in New Mexico, right, but as you say, in the globe. That's the ultimate goal of this research.
So with this research, how do you think students at WNMU have an opportunity to really learn about the future of agriculture?
Well, that's actually, we don't have many research opportunities for our science students. And the beauty of this project is that it's interdisciplinary. Right now, we have students that are majoring in chemistry, some of them are majoring in botany, even business students can get involved in the project. So that's good. And along with performing the research, I mean, the students get the actual, you know, the scientific method, how it becomes a reality, and they don't only see it in the books. And it opens them doors to present their research at national conferences, not besides the local meetings. I think so far the response, the students are very excited and they become very motivated. They take care of their plants pretty well. And every stage, you know, they say, I want to see what's next. I want to see how my plant responds. So it really becomes their project. They totally take it in. And that's something I wasn't sure that could be achieved with undergraduate students, but they actually become very responsible. And this is a great tool for their future careers.
How big of a future do you see this career path going? You mentioned the need for to address food insecurity across the globe, but where are we at right now with this issue? I mean, it seems like with what you described at where we would be in 2050 it's kind of an alarming news. So are we behind right now in where we should be addressing this issue? Or do you think that, you know, there needs to be, we're right where we need to be? Or, I mean, how big of an issue do you see this playing out?
I think it's a big issue, and at least the Department of Agriculture, it's taking it very seriously, and that's why we have available funds to look at this alarming situation. So if we think about it, it's 30 years from now. It's really close, like you say, it's alarming, right? But we scientists are trying to get there as soon as we can. And it's not only about agrochemicals. In fact, nanotechnology is playing an important role in agriculture. You know, they are developing sensors, nanosensors, to communicate with the plant. So we have the nanopesticides. It's more efficient. How can we use water more efficiently through the use of nano chemicals as well? So it's a whole team of scientists working in different aspects, but all of us looking at the food shortage that that it's estimated to happen soon.
Now, speaking of one of those issues that you brought up, water, it's obviously a major issue in New Mexico, across the Southwest, as we deal with the drought and how to address that issue. So tell me how you think a little bit more about how you think this could shine an issue on water and the production and efficiency of agriculture?
Well, some studies have shown that through the application of certain nanomaterials, plants become more resistant to drought. That is the next stage on this research. Right now, we're testing only salt stress, which is also a major problem in the world in lands. But according to studies that have been conducted somewhere else, they have shown positive effects where the plants become more resistant, and even when they are short in water, they still can produce the fruit.
Now, you mentioned salt being such an issue. Can you share with us where this issue is really affecting agriculture across the globe? I know obviously it's a major issue here in the Southwest and in New Mexico, but what other regions that depend on agriculture for their economy are facing this issue?
Well, I guess every place where drought is an issue, then the accumulation of salt, it's a consequence. You know, the salt, it's remaining in the soils. The soils are dry and they are high in salts. And of course, plants cannot tolerate that. They die right away. In most of the cases, they don't produce any fruit. And I think it's especially a problem in those places that have higher temperatures recorded than in the past, and the lack of water. They usually come together, you know, drought and salt accumulation.
Do you think with the drought and the higher temperatures that we're going to see agriculture change here in our country and perhaps be relocated in different parts of the country with warming temperatures?
Well, I wouldn't say that we could relocate agriculture, right? That's why we're trying to rescue the land that is not arable anymore. So this land, some people or some farmers, they say, okay, my land, my soil is already not fertile enough, so I should move somewhere else, you know? So we're trying to address the issues in different situations on different land, so we can rescue them and continue producing.
I mean, we've seen the change.
That's the idea behind it.
Do you think there's still time to do that here in New Mexico with this research?
I do. I have faith, and I really see positive results, you know? And the other way is just making sure the safety of these chemicals. At the end, they are not regulated yet. So we're looking at two aspects: the application, right? Are they useful? How useful they are? But at the same time, we're trying to look at the safety, you know, that they are not harming the plant, or they are not harming the organisms in the ecosystem, in the soil. You know, we have bacteria, we have worms, so we're looking at that aspect too. So that's what makes this research a little bit slower. But of course, I'm not the first one doing this type of research, and there's a lot going on. I would say it's probably 10 years ago it started, and so far the changes have been tremendous. At the beginning, people were really afraid of them, thinking that they were toxic. And when they started evaluating the toxicity, they found the opposite. Oh, they are not toxic. Actually, they are helpful to the plant. So I think we're at a good stage at this point. And some agricultural stations are already testing them, you know, in the fields with more realistic scenarios, and the results are promising.
Now, obviously, some promising things that agriculture producers may be interested in is just the affordability and cost. So tell me a little bit more about that, and is it going to be more affordable to produce with this type of nanochemicals?
Yeah, that's one of the ideas. The cost, it's comparable when you purchase a nanochemical versus a traditional chemical. The difference is that we're expecting to use way less. Let's say if you were going to use 1 kilogram in your land of a regular material, you're going to be using half or maybe a quarter of a kilogram. So the cost is going to be reduced, and as well as the environmental impact, because the plant is going to be able to get it all, and none of it is going to go into the groundwater or the air, which also reduces pollution levels.
Now, I wanted to talk to you, I'm glad you brought that up because I want to talk with you more about that. How do you think this can address pollution? And obviously there's been a lot of reporting about how chemicals in agriculture are impacting farm workers and people working in the industry. So how do you think this can make a difference in that area?
Yeah, well, the rationale behind that is the amounts, right? That the size makes it easily available for the plants, and because the plants don't have to be, fighting or competing, because of the size is so small, they can just pass through, cell membranes, etc. So because of that, they're just easily taken and you can use less. So the environmental impact comes from the amount that we're going to be using, which is should be less than traditional agrochemicals. And also a lot of the agrochemicals currently used, they end up going into the groundwater, right? And polluting also our waters. With this approach, the plants should be taking them immediately. And we're also testing 2 different application forms. We're applying some of the chemicals foliarly, right? Spraying them on the aerial part of the plants, or also in the soil. And we want to see which way is more efficient, which way we can use less, and also to see which way we lose less amount into the environment.
Where do you see the future of this research going? I mean, it's fascinating stuff, and you mentioned it's been underway for around a decade or so, but where's the future of this? Obviously, a lot of attention is going to be paid towards this type of research as the planet continues to have warmer and warmer temperatures and more drought affecting agriculture. Where's the future going with this?
I believe that people is going to start looking at agriculture more, because I feel that at some point people took for granted that we always had food, right? And then even a lot of farmers decided to leave their lands and move to the city, work at an industry or something like that. But now we're going to be facing this food shortage. So I believe that a lot of people is now looking at agriculture, but not only from the point of view on how to do it, but on how to improve it. So I even had a lecture last week with some of my freshman students, and I talk about agriculture. I just gave a lecture on agriculture, and I asked them, do you know that agriculture was a science? Do you know how relevant was agriculture for you? Not only in terms of giving you food, but all the other things that it provides. And most of the students say that they didn't know the importance of agriculture. They never thought about it. They didn't even think it was a science. And I asked them, would you consider going into, a career in agriculture now that you see all the things that have to be addressed? And a few of them say yes, and they found it very interesting. It's something that sometimes we just take for granted.
I mean, it is an issue that I think a lot of people may not be too familiar with, or just how big the industry is. Obviously, if you live in certain parts of the country, you recognize that. Our part of the country is one that deals with many of the challenges with agriculture in certain industries. Obviously, it is very important to our economy and our workforce, but also drives a lot of education and research that we have here in our region. So I kind of want to hear from you, if you could kind of just carry on a little bit more about what you talked about. Give us some perspectives on how agriculture has changed in the last 30 years. People might be surprised.
Yeah, I guess, it changed since the invention of the tractor, right? So everything became more mechanized. And then we have just a few years ago when we started doing genetically modified organisms, that completely changed agriculture. We were able to develop resistant crops, and that was, a lot of people still against it, but it gives us more food, right? And then now they call it the internet driven agriculture, where we're going to be using internet resources. As I mentioned, I have read a little bit about this nano sensors, where the plants are giving this little sensor, and the plant can tell you if it needs water, if the temperatures are not appropriate, if some concentrations of the nutrients that it needs are not in balance. So now we're at that stage where technology is allowing us to communicate really with the plant through an application. So at some other universities that are more engineering, technology driven, they are working on those approaches. So now it's really the Internet of Things, right?
How do you think that technology is going to change the industry, though? There are some producers that are very concerned about their labor force. Do you think that this can address the producers who may not have enough labor to really harvest the crops?
Yeah, that's another area, right? Robotics can definitely play an important role, because if we are talking about increasing production, but we don't have enough people to actually harvest, so over there, engineering technology can develop the tools so we make sure that the food doesn't go to waste.
Why did you want to get into this sort of research? Was there anything particular that you experienced through your education that made you really want to go into this type of research?
Well, I'm really fascinated about agriculture, and I started looking into agriculture in my graduate studies. And the truth is that I started doing research in nano-chemicals, but I was evaluating the toxicity. I was studying zinc oxide nanomaterials, and when I started, I remember doing my experiments and then looking at the results, and nothing wrong happened, nothing is bad. And I was a little bit disappointed at the beginning, as a grad student, you want the best results. And that made me think this is actually a good thing. It's good that they are not toxic. It's good that they are giving me a positive effect. So when I graduated, I decided that I wanted to do research in applications. And I started reading more about that, and then more articles became published and more. So it was interesting because I started looking at them as the bad guys,
Right.
And then I end up finding them as a great opportunity to improve our agricultural practices.
As somebody who is working in higher education, how do you see the future of agricultural study going? Do you think that there are enough students that are going into the field right now?
I don't think so. And I think it's because they are looking at it at the traditional way. Okay, if I'm going to be into agriculture, I'm just going to have a farm and produce my food. But there's way more involved in agriculture. As I say, it's all the technology, all the science behind it. Of course, the business portion of it, right? We talk about having an area of agriculture just called business agriculture. So I just think it doesn't get enough what's the word, promotion on all the things that you can do with an agriculture degree.
How do you think that this research that you're doing right now can play a role in that?
Can you repeat the question?
How do you think that the research that you're doing right now could maybe attract the next generation of agriculture professionals?
Yeah, that would be great, right? And as I said, a lot of the students that I have in my research, we don't have an agriculture degree, they are like from botany or chemistry, but they really, at the beginning, they struggle because they are not that familiar, with the crops, how to take care of them, but they just become very confident, and then they start considering, first of all, grad school, right? Because a lot of them, they didn't think that they wanted to do graduate studies, and then a lot of them say, okay, I want to do into some food or agriculture or something related, because they find it very, very interesting, and they really think that what we are doing can save the world from hunger.
Well, can you share with our audience how they can find out more information about the research that you're doing?
Yes. Well, I have some publications online if you just look for my name, but also you can look at WNMU.edu, the website, and there should be a link there to find more information about it.
Dr. Illya Medina, thank you so much for joining us. She is Assistant Professor of Chemistry at WNMU. We appreciate you taking the time to share this fascinating research.
Thank you.
And we want to thank you for joining us for Fronteras, Changing America. I'm your host, Anthony Moreno. We'll see you next time.